7 says a 12-pack of Omni Cola mass 4.3 kilograms is initially at rest on a horizontal floor. It is then pushed in a straight line for 1.2 meters by a trained dog that exerts a horizontal force with a magnitude of 36 newtons. Use the work energy theorem to find the final speed of the 12-pack if A, there is no friction between the 12-pack and the floor. So we'll stop there and do that one, then we'll come back to B. So for A, this is kind of our setup here. We've got normal force and gravity, which don't really matter for this, and then the 36 Newton force there. And then our equation to solve for work is this guy, the work equals force times cosine alpha, or cosine theta times displacement. So our work is going to equal the force, which is just the 36 newtons on this one, times the cosine of theta, which, since the box is moving this way and the force is this way, it's going to be the cosine of 0, which is 1. So showing more about it. So 36 times the 1.2, the displacement, equals 43.2. Now using the work energy theorem, whatever, we can just set 43.2 equal to 1/2 mass, which is the 4.3, times velocity squared. And that comes from the idea that work equals change in k equals 1/2 mv squared. So we've got that set up now, and we're just going to solve for v squared. So 1/2 times 4.3 is 2.15. So v is going to equal the square root of 2.15 of 43.2 divided by 2.15. And that should equal about, can you see down there? Yeah. V equals 4.48. Part B, which we can do over here. Part B of 27 wants to know the same thing, but this time there's friction. So the coefficient of the kinetic friction between the 12-pack and the floor is 0.3. So our friction is going to equal 0.3 times the normal force for friction. So I'm just going to use the same diagram, but now we've got friction going this way. This is our friction that we'll solve for. So we've got to start out by finding the force of friction on this one. So we know that friction equals the coefficient times the normal force. So our friction is going to equal 0.3, the coefficient, times the normal force, which is going to be the weight. So 4.3 kilograms times 9.81 gravity. Which is going to give us 12.6549. And we can plug that in to the same equation here. So work is going to equal, it's going to equal the total force, right? So we're going to have the 36 minus 12. Point. And this is a minus because it's going in the opposite direction. So if we have a reference frame right here, this is our positive x and our positive y. This is going in the negative x direction, negative. And then the direction of the force is still going to be the same as the displacement, so that's still going to be 1. Cosine of 0 is still going to be 1 times 1.2, which is going to give us a work equals 28.01. Set that equal to velocity squared. We're going to end up with v equals the square root of 28.01 divided by 2.15 equals